Imagine a world millions of years in the future. A world where evolution has written a new chapter in the story of life. The world is inhabited by very strange creatures, like nothing the Earth has ever seen. 100 million years in the future, this vast plateau stretches for thousands of kilometers, with peaks of over 12,000 meters above sea level, higher than the Himalayas of today. It took millions of years to build this plateau. It was formed because the Earth's continents are sitting on huge plates that are moving very slowly across the face of the globe. And at some point, it's inevitable the continents will crash into each other, crunching up the land, creating mountains and high plateaus.
Well, much as India, by colliding into Asia in the present day, has created the Tibetan Plateau and the Himalayan mountain range as the largest and highest mountain range on the Earth, so too Australia, 100 million years in the future, in its northward journey is ultimately colliding with the southeastern portion of Asia, and indeed pushing up an equivalent to the Himalayas, except potentially even larger in extent.
Eventually, Australia collides with North America and Northern Asia as well, continuing to push up this vast plateau. On such a high plateau, the air is cold and thin, and snow covers the peaks all year round. Not a very inviting place for any creature. Yet every year, this bird migrates to the plateau, the great blue windrunner. A giant blue bird with a 3-meter wingspan. It spends its winters in the lowlands far to the south, but each summer it flies thousands of kilometers to reach this bleak, harsh plateau. And this is no ordinary bird. To soar at such a high altitude, the windrunner has 4 wings.
The bird we're going to find on this plateau is something completely different. At first it looks rather like birds you'd see today, birds you'd even see in the Himalayas today. But this one's special. It needs to go high up, and it's going to fly in very thin air because it's high altitude. The problem the bird has is how it can be efficient flying like that and yet also be able to take off and land, to dive down, to maneuver. All these difficult things. Birds today have exactly the same problems. They have to juggle being good fast flyers, good manoeuvring, perhaps good at escaping predators or catching their own food. And wings have to evolve within all these different constraints. Some birds have long wings, some have short, some have very pointed wings, some have very rounded wings. And the bird has to compromise the shape of the wings it has and the variety of types of flight it's going to use. Now in the future on this Himalayan plateau, these compromises have just got too difficult. You can't do it with wings built as they are now. So the windrunner's solution is to use the legs as well. Because it spends so much time in the air, it doesn't need to use its legs for running in the same way that modern birds have to. So it's turned them into a flight surface. When it flies with just the two wings, its four wings built of the arms, it's just like a modern bird. But when it swings its hind legs forwards, they become more wing. The surface goes up. And the result is it's much cheaper for the bird to fly. It can go further, it can go more slowly so it can see the ground better. And this is a way of extending its design envelope. It's not restricted to just one type of thing, it can do a great deal more. Perhaps it's been forced to do this by the stress of living in a very extreme habitat.
The windrunner has a long neck, like a crane, and it's developed small winglets called canards to support its head during flight. With its back legs spread out, this amazing four-winged bird can soar for hours at a time in the thin air over the plateau. But up here, gliding above the mountaintops, the windrunner has another problem to face. And it solved that problem by colour.
The great blue windrunner is a strange powder blue colour. This bird is living on a very high plateau. High altitude means high level of ultraviolet light. That's both a threat and an opportunity for the bird.
Ultraviolet is invisible light off the blue end of the spectrum and is filtered out by the atmosphere. But in the thin air of the plateau, the bird relies on its special feathers to reflect the ultraviolet, giving the windrunner a strange blue fluorescence. All these special adaptations mean that the windrunners can visit the plateau every year to breed. Both parents feed the single chick, which can tell its parents apart, even though to us they look identical.
The main reason for the blue coloration of the great blue windrunner must be the protection from ultraviolet light, because without it that would be incredibly damaging. But these colour patterns give it another advantage. The animals can use the ultraviolet light to communicate signals to each other.
In ordinary light, windrunners look identical, but reflect ultraviolet differently. As they also see in ultraviolet, they can recognize each other by their unique patterns. Cold, thin air, ultraviolet radiation. This seems a harsh place to rear a chick. But there's a very good reason the windrunners come here to breed. A gigantic spider's web strung across a ravine 30 meters wide. In fact, there are hundreds of webs draped all over the valleys and ravines, spun by silver spiders. The spiders look silver because it's their way of protecting themselves from ultraviolet light by reflecting it. To make webs this big means working together as a group, something only a few spiders do today.
The social spiders that exist today tend to be species that build irregular webs that require a lot of silk. And one of the reasons we think that sociality may have evolved in those groups is because the silk is expensive, and individuals, by remaining together, they are able of saving on the amount of silk that each individual needs to invest to maintain the web.
Working together and combining their effort is one thing, but organizing themselves so they share out the work, division of labor, is something else.
The social spiders of today, one interesting feature of them is that they do not have any kind of division of labor. Everybody reproduces and everybody works. But a possibility is that in the future, spiders might have evolved some kind of division of labor.
In the future, silver spiders are divided into castes, depending on their age and size. They're larger than today's spiders, so the smallest and youngest, the line caster, has to start the web by floating across the ravine using a kite made of silk and floating seed heads. The line caster relies on luck and a fair wind to float to the other side, where it attaches the line to the rock. Once the first line is secured, another caste, the bigger web builders, arrive. They venture out onto the first lines, spinning behind them stronger tether lines that will make up the framework of the web. After that, individual spiders spin webs to fill in the gaps. But unlike the webs of today, which are designed to catch insects, these huge structures are designed to trap seeds. Seeds of the grass tree. Grass trees are descended from bamboos, and every summer, for a few weeks, they fill the air with their seeds. Their tough woody stems are strong enough to withstand the wind, and the grass trees use the wind to their advantage, just like grasses of today.
Well, modern grasses are largely distributed by wind. They simply create huge amounts of seeds, and these are blown. Sometimes these may also be trapped on the surface of animals, such as when they become trapped in the surface of your trousers or your socks. They may be eaten or carried around by small animals, but it's a very unspecialized dispersal system.
It's not just grasses that use the wind to disperse their seeds. Dandelion seeds are carried on the wind by elaborate parachutes, taking them miles away from the parent plants. In the future, the grass trees have evolved large parachutes to carry their seeds.
So what we have imagined for 100 million years in the future is that the dispersal system remains relatively unspecialized, and that frequently they are blown in great clouds through the air. But instead of just landing somewhere on the ground and germinating or being picked up then by some little animal that walks off of them, what we're envisioning is that somebody has taken advantage, as it were, of this bounty that is blowing through the air mass. And this is a spider which is making a very large web that is catching and trapping not insects, but the seeds of the bamboos.
During the summer, as many as 100,000 seeds a day are caught in the silver spider's great web. Worker spiders spend all their daylight hours collecting the seeds and ferrying them into crevices on the sides of the ravine. These deep crevices have been eroded by wind and rain and provide a secure home for the spider colony, and somewhere to store their annual harvest of grass tree seeds. Silver spiders live in a very efficient society. Different castes do different jobs, And the whole system is held together by a central figure, the huge, bloated queen. She is the only spider to breed. The other spiders tend to her every need. All the queen has to do is lay eggs. Despite all these spiders, the crevices also shelter a small, shy rodent. A poggle, the very last of the mammals.
It's 100 million years in the future and most mammals have now gone extinct. One of the few mammals that's left is a small hamster-like rodent that's probably evolved from a social rat. Even today, the mammals are doing badly. Many species are going extinct, and over the next few 100,000 years, we're going to lose most of the diversity of the mammals we have today. All that's likely to survive are some of the more successful groups, such as the rodents. And even then, they're not going to have the competitive advantage they've got today, because as the world warms up, other species will adapt and expand, and the advantages that mammals have will become less and less. So within 100 million years or so, they'll virtually be on the point of extinction.
The poggle is the last mammal ever. All the rest have died out. These last mammals spend all their lives in a dark cave at the mercy of a colony of spiders. Yet most of the time, the poggles seem to be ignored by the spiders, hiding in the shadows and snatching seeds when they can. It seems strange that, having gone to all the trouble to collect the seeds, the spiders just let the poggles help themselves. But it isn't always like this. Just sometimes, the spiders seem to change their minds and attack. Then the poggle is dragged away to be eaten. In fact, the spiders are farming the poggles, feeding them seeds to fatten them up for the slaughter.
The spiders get two things from feeding the puggles. The puggles are very prolific and they produce lots of youngsters. And so some of the youngsters are actually eaten by the spiders and they're a food source.
The poggles are the spiders' only food source. The spiders collect their rich harvest of grass seeds, and the poggles convert them into flesh. But there's another more sinister reason for the spiders to farm poggles. The queen.
The queen spider feeds on the blood of the female breeding puggle because the hormones produced by the puggle actually stimulate the reproductive system of the queen spider.
So one question we may ask is why these spiders have developed this complicated relationship with these mammals. They first collect the seeds to feed the mammals. Why don't they just eat the seeds? And the reason for that may be because they have not been able to change their habits from being carnivorous, feeding on insects, to feeding on plants. The way spiders feed, they paralyze an insect and then inject chemicals, these enzymes that will digest the insects, and then they suck up the juices out of these digested insects. But so their mouth parts are specialized for this kind of activity. And they may not have been able to change their mouth parts, their sort of feeding apparatus, to chew on plants the way it would be required to feed on plants instead of on these pre-digested insects. But another possibility is that in order for these queen casts to develop, that is, these individuals that lay the eggs and reproduce, they may have perhaps used some of the chemicals that they get from the puggles to perhaps control and suppress the reproduction of other members of the colony. So in that sense, the spiders would depend on the puggles both for food and for developing of these queen hormones. And at the same time, the puggles would depend on the spiders for a collection of seeds. And that way they would have developed a relationship that makes them dependent on each other.
The spiders thrive on their diet of puggles, and so many spiders are a feast for the windrunners. This is why they fly all this way to breed. Up on the high plateau, with plenty of spiders to eat and no predators, life seems safe for the windrunner family. But the Great Plateau is still moving, still restless, and at times shaken by earthquakes. And sometimes the earthquakes are more serious. It isn't just the plateau that's restless. Now it's the whole planet.
Million years in the future, we've entered a period of increasing volcanism, and initially what this did was led to a greenhouse effect. CO2, carbon dioxide, built up in the atmosphere and led to a global warming, and in that in turn created a proliferation of life. But volcanoes have their downside as well as their good side. They can lead to global warming, but in sufficient quantity, with enough explosions, enough massive distribution of volcanoes, they can start to emit a large quantity of other things as well. Sulfur, perhaps, is one of the most common. This can lead to an acidification of the atmosphere, of the oceans, and ultimately to a mass extinction.
A mass extinction is a worldwide disaster. A time when whole groups of animals disappear and the majority of life on Earth goes extinct. Food chains are broken, whole ecosystems collapse, and life teeters on the brink of annihilation. The world's climate changes dramatically, and very few creatures will be able to survive. Many of the specialized creatures, like the great blue windrunner and the silver spider, are doomed. Mass extinctions have happened before in the history of life on Earth. What, if anything, can survive a mass extinction of the future? In this future world, a harsh, barren desert stretches for over 9,000 kilometers. At its center, it seems too hot and too dry for anything to survive. But in a few places, there are isolated pools, and where there's water, there's life. And these mounds are insect cities, each a fortress defended by armies. Armies of terabytes. This desert is so big and so dry because of something that happened. Something that changed the planet beyond recognition.
200 million years in the future, all of the continents come together to form a supercontinent. And this is simply a replay of what has occurred in the past in Earth's history. 200 million years in the past, we had the supercontinent of Pangaea.
The Earth's crust is broken into vast plates which move very slowly over the face of the globe. Yet, even looking ahead 200 million years, we can predict their movement. Eventually, the continents will fuse into one huge landmass, and this will affect the climate.
One of the things that happens when all of the continents become grouped together, you have one huge landmass surrounded by one huge ocean. This has an influence on climate, and the climates become more extreme.
So we can even predict the future climate because it depends on the shape of the land.
Anywhere where there's a mountain range near the ocean, the inner side of that mountain range is going to develop a rain shadow. And then even more strongly as we move into the center of the supercontinent, getting increasingly distant from the sources of oceanic moisture, the continent dries out. And the center of this supercontinent, much like Pangaea in the past, will be an enormous desert.
This desert is so vast and parched, it's a serious challenge to life. But all the creatures that do live here are lucky. They're the survivors of an even greater challenge to life, an event so cataclysmic it reshaped the whole pattern of life on Earth. 100 million years earlier, volcanic eruptions increased, throwing dust into the atmosphere, blotting out the sun, chilling the Earth, and creating an event we call a mass extinction.
A mass extinction is when a very substantial percentage of the species that are alive on the planet disappear in a very short period of time. Now, a short period of time to a geologist might be 10, 15, 20,000 years, but relative to the millions of years that we're talking, this is it's like that.
Mass extinctions have happened several times before in the history of the Earth. It's certain one will happen again. And each time it happens, life suffers a heavy blow, and very little survives.
What do we have left? Only those few organisms that are generalist enough to get through that period of environmental transition. And for quite a period of time after the mass extinction, the world is going to be a fairly lonely place because there will be very few organisms that actually made it.
But something did survive. Creatures so tough they survived several mass extinctions before this one. Creatures plenty tough enough to survive even in the harsh desert. Terabytes. Descendants of termites, they made it this far because they're insects, some of nature's greatest survivors.
Insects have been around an extraordinarily long time. 400 million years ago, they came out onto land along with the first plants. They've survived everything that nature has been able to throw at them since. So they passed through the greatest mass extinction we've seen, 250 million years ago or so. They survived perfectly well the demise of the dinosaurs. In fact, this was a time when, in some ways, they were still diversifying. And I've no doubt at all that whatever happens in the future, if anything survives, it will include the insects. We know that in the most inhospitable places in the world today, like the deserts of Namibia, there are beetles, there are ants, there are a number of insects that are able to cope with an environment that's too hostile for almost anything else. So if anything's going to survive in such a grisly habitat, it will be insects.
Scorching heat and no water. No problem. Terabytes built cities, 2-meter-high mounds, and each city shelters millions of insects from the desert sun. But terabytes can't hide in their cities all the time. This is a raiding party. Like their termite ancestors, terabytes are vegetarians. They're setting out to harvest the plants around the pool. But in this desert, the plants can run away. They're not plants at all. They're animals, giant green worms. And when the terabytes are on the warpath, the worms escape, slipping into the safety of the pool. They're not plants, but they do seem to have something that the terabytes need. Garden worms look like plants, but the leaves are fleshy lobes growing out of the worm's body. But they don't just look like leaves. They work like real leaves because they're packed full of tiny, green, single-celled plants, algae. Algae make food from air, water, and sunlight. The garden worms live off this food and nothing else. A clever trick that's been invented before.
It's a curious fact that many animals have learned to live symbiotically with algae. There are even flatworms which are bright green because of the algae within them. They don't have any normal stomach, they absorb food directly, and they have to bask in sunlight to grow their own food, if you like.
These convoluta worms depend on the algae inside them for food, so they don't need a mouth or a gut. But without their algae, they'd starve. Basking in the sunshine is like eating a good meal. But sunbathing is only safe at low water. As the tide floods in, the worms disappear back into the sand or risk being eaten by passing fish. All the delicious, conveniently packed algae in the garden worms are there for the taking. So to stop the worm long enough to grab some of the algae, terabytes deploy their chemical weapons, a sticky glue. It takes a lot of glue to slow down a worm, but terabytes have a special cast, gum spitters, that do nothing else.
The termites of the future have taken the social caste system that they have today even further. They now have a specialized caste of transporters that carry other specialized termites around to do different jobs within the colony. So the transporters will take individuals with the chemical weapons to where they're needed. They'll take biters to another place. So the whole system has gone up one level of complexity.
But for every chemical weapon, there's a chemical defense. The worm secretes a substance from between its segments that dissolves the terabyte glue. And the worm can escape. Minus a few algae. Measure and countermeasure. Chemical warfare has been around for a very long time.
This form of defensive action is known today. For example, spider webs are extremely gluey. And most insects, when they get stuck, that's it. They're dinner. But one group of insects, the scorpion flies, has a special secretion. It can wipe on its limbs so that when it becomes entrapped in a spider's web, this secretion actually dissolves the glue, enabling the fly to escape.
The pools that shelter the worm don't dry out, even in the baking desert, because they're connected to a vast underground reservoir. They're gateways to a secret world hidden deep below the surface. A huge network of caves and caverns, underground rivers and lakes. However hot it gets on the surface above, these caves stay at the same temperature all year. Dark and cool, running for thousands of kilometers under the desert. This is where the garden worms live when they're not out sunbathing. But there are still terabytes down here. Wherever there's a pocket of air, there are strange blobs. These are terabytes as well, but a different form again. And there are hundreds of them, 20 meters below ground. The blobs are water carriers, and their only purpose in life is to drink. And drink, bloating their bodies with water. Transporter terabytes run a regular ferry service to and from the caves, carrying the fully loaded water carriers back to the nest far above. Water carriers are a living irrigation system. Terabytes don't just eat the algae stolen from the garden worms, they farm it on specially built platforms, tending and nurturing it until there's enough food to feed the whole colony. A water carrier's job is simply to water the crops. The tops of the mounds are like greenhouses, with translucent windows of hardened gum that let in sunlight. But the really ingenious parts of the nest are hidden below ground, at the bottom of the mound. Several meters below the desert, the terabytes have built their own air conditioning system, layers of veins built from mud and sand. Water carriers also keep these veins damp, and as the water evaporates, it cools the veins and the air between them. A complex series of tunnels and ducts allows the air to circulate. Cool air sinks around the outside walls, drawing warm, carbon dioxide-rich air from the nest chambers into the greenhouses above. A perfect hothouse design to make the algae grow as fast as possible. It's simply an advanced version of today's insect agriculture.
Many insects today use some form of cultivation. In termite mounds today, organic material, leaves, twigs and the like is brought into the nest where it is broken down by a special kind of fungus. And it's this fungus which provides the nourishment for the colony. In leaf cutter ants, leaves are cut up and transported back to the nest where another kind of fungus, another special kind of fungus, breaks down the leaves into a form that the ant colony can use. So this kind of gardening is actually quite widespread in the insect world today. What we're doing in the future is discovering a termite which, instead of using fungi, is actually cultivating a kind of algal scum which it can graze on directly.
advanced cities, an elaborate caste system, greenhouses built to feed the millions. But as in all cities, everything depends on one vital part of the system: plumbing. Water comes from underground, 20 meters below the surface, under tons upon tons of hard limestone rock. So the whole system depends on tiny insects getting through all the rock. This is the job of yet another caste, the rock borers. Like glue squirters, they do nothing but make chemicals. In this case, concentrated hydrochloric acid, which dissolves the limestone. Working together, rock borers and biters with strong jaws can burrow through solid rock to get to the water below. The caves run for thousands of kilometers under the desert, a long way from the sunlit pools above. Yet they're full of life and aglow with light, a very weird light.
Underground, in these deep caves, the conditions may seem rather unpleasant for life, but they are entirely suitable for some specialized kinds of bacteria. The caves are lit with the bioluminescence, the natural light that these bacteria produce. Bacteria, in fact, are capable of living everywhere, no matter how inhospitable the environment. Go to a boiling hot spring, some bacteria love it. Bacteria are ancient organisms. They've been around on the Earth for at least 3,000 million years, during which time they've colonized every conceivable habitat. Many of them live today in places where you think nothing could live. In fact, they form the basis of a food chain. For example, on deep ocean ridges, hot water charged with sulfur moves up from the interior of the Earth. Bacteria love it. Special sulfur-loving bacteria live there in enormous profusion. And they in turn provide food for a whole series of specialized organisms that live there. This is a special enclosed world powered by bacteria. "200 million years in the future, bacteria just like these could be living off minerals dissolving from the rocks. These microbes form a bright, day-glow green turf, dinner for other, bigger creatures. Half-a-meter-long gloomworms feed on the glowing bacteria. And even larger creatures feed on the gloomworms. This is a slick ribbon, a meter-long killer worm. The predator of the caves.
The worms in the cave have evolved there. They've been isolated in this cave system from the rest of the environment, the desert up above, for a long, long time. And the species that are now in that cave system that form an ecosystem there have all evolved from a common ancestor.
That common ancestor was a kind of marine worm, a very successful, diverse group. Along each side of their bodies are 2 rows of complex structures that can be used for burrowing or swimming. In today's seas, this design works so well there are thousands of different kinds of marine worms, but they were almost annihilated by the mass extinction. But one kind of worm must have escaped into the cave system. Isolated in its own dark world, that one kind evolved into many different forms, what's known as an adaptive radiation.
They've been isolated. The environment has been open to them to explore in an evolutionary fashion, and they have generated a small adaptive radiation in order to evolve into these different niches that this cave system represents. adaptive radiation of this kind is really something we see all the time in the current modern world, especially in island archipelagos. For example, Darwin's finches are a set of birds that are different species on the archipelagos of the Galapagos Island off the coast of Ecuador. They blew there who knows how long ago and diversified into different species using the habitat in different ways.
With no competition from anything else on the islands, the finches had room to spread their wings. They evolved different-shaped beaks to feed on different kinds of food.
Even more spectacular is the radiation, the adaptive radiation, of the Hawaiian honeycreepers, which have evolved very different bill shapes, very different sizes, very different food types, all from the same ancestor to take advantage of the highly diverse habitats that they found when they stumbled across the Hawaiian archipelago.
Isolated for millions of years under the desert, the worms evolved into several very different species. Eventually, they became gloomworms, slick ribbons, and garden worms. And most of them live out their lives in the perpetual underground gloom. But it's still a matter of life and death down here. Slick ribbon and garden worm. Predator and prey. The garden worm has a special defense, squirting out a disgusting liquid right in the path of the slick ribbon, buying the garden worm just enough time to get away. Far above the world of the cool caves, the largest desert the planet has ever known. Yet life still hangs on. Strange desert insects, walking plants, killer worms, all survivors of a devastating mass extinction, living out their lives in a strange new world.